Hello, this is a demonstration to show a deboring operation using ABB robot to establish the communication in the industry between the robot and the PLC. In this particular demonstration, the robot is the slave to the PLC. The PLC performs, or rather instructs the robot, gives the robot service request, the robot executes, and at the point of the service execution, the PLC also instructs the robot on which particular task and when to perform the task. Notice on our pendant currently, the robot is on auto, and the robot is running, looping infinitely, waiting for the instruction from the PLC. On our PLC, we are going to give the robot a 10. Notice that the robot moves back to the ready position and then comes back to perform the top deboring operation. The robot has stopped because it is waiting for the task instruction from the PLC, which is DIN64. So we go back to our PLC, DIN64, and we turn that on. Then the robot starts performing the deboring operation. The robot does a single debore operation and then notifies the PLC by giving the feedback that it has completed that task. And the PLC is expected to turn off the service request operation for the robot to go back to its ready position. When the robot has completed the deboring and gone back to its ready position, the robot waits for the PLC to update the output of the service request. So the robot updates the output, the PLC updates the output to 0. The robot goes back to its main program and loop continuously, waiting for the next instruction from the master, which is the PLC. So to do a side debore, notice that the input 00 from the PLC need to be set to 11, the integer input. So to perform a side instruction, we set our input to 11. Notice that the robot moves to the debore ready position. It is executing the instruction being given to it by the PLC. Notice that the robot, even when it is currently at its ready position, will not perform any instruction until the PLC sends the task execution request. Notice on the program that our pointer is currently pointed to DIN64 and is waiting for it to turn 1. Once again, we simulate by turning the input 1. Notice that the robot now goes in to perform the deboring operation. When the robot has completed the deboring operation, the robot once again updates the PLC that, hey, I have completed this operation, and the PLC will turn off the task request signal. Then the robot goes back to its ready position. When the robot has gone back to its ready position, it gives a feedback again to the PLC that, hey, I have completed the service request by updating the input, waiting for the PLC to clear out the previous service request. The PLC sets the service request to 0, and then the robot goes back to its main and loop continuously, waiting for the next instruction. Notice that if there is any integer that is not the integer that represents the specific service request being coded in the robot will ignore that integer. Recall that for this demonstration, we are using 10 for top debore and we are using 11 for side debore. However, if I put a strange number like 20, notice that the robot does not do anything because 20 is not coded in its service request. The robot is still looping in its main program, but it's not executing the instruction from the PLC, which is not within the specification of the if-else conditional statement coded in its memory. However, if I put 10, the robot understands that 10 means the service request from the PLC to go and do a top debore. The robot moves to complete the top debore. Once again, the robot waits for the task request from the PLC. The PLC instructs the robot by turning on the digital input 64. The robot goes in to perform the operation. As the robot is performing the operation, it updates the PLC that, hey, I have acknowledged this task request that you have sent to me. When the robot finishes performing the operation, the PLC removes the task request for the robot to know that it has acknowledged that the robot has completed the task. Once again, the PLC also updates the service request to 0, and the robot loops continuously in its main program waiting for the next instruction. Thank you.